You were there. You know you were there. There are photos, there's video, people who held you and talked to you and sang to you for hours. But if you try right now to actually remember any of it, a face, a sound, a single moment from before you were about 3 or 4 years old, there's nothing. Not blurry, not faint, just gone. Like it never happened to you at all. This isn't just you. This happens to every single human being who has ever lived. Scientists even have a name for it: infantile amnesia. And for over 100 years, nobody could fully explain why a fully functioning, learning, emotionally responsive baby brain produces zero usable long-term memories. So let's actually open up the file and find out what's going on. The part of your brain responsible for stitching memories together long-term is called the hippocampus. In adults, it's basically fully wired. In infants, it's still under construction. Neuroscientist Paul Franklin at the University of Toronto found something that initially sounds backwards. Baby brains are actually producing huge numbers of new neurons in the hippocampus at a much faster rate than adult brains do. You'd think more new brain cells would mean better memory. Franklin's research suggests the opposite. That flood of new neurons may actually disrupt the existing connections needed to lock a memory in place long-term. It's less like a filing cabinet losing papers and more like a filing cabinet being aggressively renovated while someone's trying to use it. Here's a second piece, separate from the hippocampus problem. Memory isn't just about storing an event. It's about being able to later retrieve and describe it, even just to yourself. Psychologist Catherine Nelson studied how memory and language development line up in early childhood and found that kids generally can't form what's called autobiographical memory, a memory you can mentally narrate as "this happened to me," until they have enough language to actually build that narrative. Before you have words for time, sequence, and self, an experience can register emotionally in the moment, but there's no scaffolding to file it away as a retrievable story. It's a bit like recording a video with no file name and no folder. The data might technically exist for a moment, but there's no way to find it again later. Most people assume infantile amnesia just covers literal infancy, birth to maybe age 1 or 2. The actual research says otherwise. Studies on childhood memory, including long-term work tracking children's recollections over years, consistently find the average cutoff for adults' earliest memories sits between 3.5 and 4 years old. And full memory density, where memories start being reliably retained the way adult memories are, doesn't stabilize until around age 6 or 7. So that one early memory you might have, a birthday, a pet, a move to a new house, probably wasn't your earliest experience. It's closer to one of the first experiences your brain was finally developed enough to actually keep. This part tends to unsettle people the most. Psychologist Elizabeth Loftus spent decades researching false memories, and one of her most well-known findings is that people can be made to vividly remember events from early childhood that never actually happened, sometimes just by being shown a doctored photo or told a convincing story by a family member. This matters here because a lot of what feels like an early childhood memory may actually be a memory of being told the story. Photos you've seen, stories retold at family dinners, home videos rewatched. Your brain can mistake "I've heard this story many times" for "I remember this happening." The line between the two isn't as solid as it feels from the inside. Here's where it gets genuinely strange. If memory before age 3 or 4 is supposed to be unreachable, why do some people swear they remember a house fire, a car accident, or the day a sibling was born from when they were 2? Psychologists call these flashbulb memories, intensely vivid recollections tied to a moment of high emotional shock. Researchers studying early childhood trauma and high arousal events have found that extreme emotional intensity can sometimes trigger stronger than normal encoding, even in a hippocampus that's still developing. essentially forcing a memory through a system that isn't fully built yet. The amygdala, the brain's threat detection center, matures earlier than the hippocampus and is heavily involved in tagging emotional intensity. Some researchers believe that during a genuinely terrifying or shocking moment, the amygdala can essentially flag an experience as urgent enough that fragments of it get encoded even while the surrounding memory system is still being built. The result isn't a full, clean memory. It's closer to a few isolated flashes, a sound, a color, a feeling of fear, without the surrounding context that would normally hold a memory together. So the honest answer is messier than a clean yes or no. Some early emotional memories may genuinely break through earlier than the usual cutoff, in fragments. But the more dramatic and vivid the memory feels, the more likely some of its details were quietly rebuilt later, by photos, retellings, or your own imagination filling gaps you couldn't actually see at 2 years old. Even the exceptions to infantile amnesia come with their own asterisk. If this were just a human language or self-awareness quirk, you'd expect animals without complex language to not have this issue. They do, though. Franklin's lab also ran experiments with infant mice, finding the same pattern. Early life memories formed in young rodents faded rapidly compared to memories formed later, fitting the same neuron overgrowth explanation found in human hippocampal development. That cross-species consistency is a strong clue that this isn't really about babies lacking self-awareness or language. It points back to something more basic and physical happening in how a developing brain wires memory storage in the earliest stages across very different species. Here's the part that reframes everything. Some researchers, including teams who've studied memory retrieval in infant mice using direct brain stimulation, have found they could artificially reactivate memory traces that should have been forgotten, suggesting that in some cases, the memory trace itself may still physically exist. It's the retrieval pathway that's broken, not necessarily the storage. In other words, it's possible your earliest experiences with your parents, the first time you laughed, the first time you felt safe, aren't necessarily deleted. They may simply be stored in a format your adult brain no longer has the key to open. So you weren't broken, and you weren't being ignored by your own memory. Your hippocampus was still under construction. You didn't have language yet to file the story away. The cutoff was later than you assumed. Some of what feels remembered was actually just retold. And even other species share this exact same blank spot. You didn't lose those years. Your brain just hadn't finished building the shelves it needed to keep them on.